Hey class, welcome back. From what I saw from the notes and the homework on Tuesday, you guys have really picked up on this finding the GCF, all right? So that's really great to see. Today we're gonna do part 2 of factoring polynomials using a GCF. All right, so we're gonna take that one step further, right, from what we did on Tuesday with finding the GCF, and now we're gonna factor out a GCF, okay? First, what is factoring, right? Factoring is finding what to multiply to get an expression. Okay, so what things multiply to get to back to an expression is factoring. Okay, so the goal of factoring is to break down an expression into parts or factors, right? Things that multiply together are the factors, all right? In factoring, you're kind of breaking things apart. All right. So the first couple of weeks of this chapter 7, right, was simplifying expressions. We were putting things together to simplify it. And now we are factoring, which is going to break it apart. All right. So these problems are going to look kind of similar to the first 3 weeks, except it's going to be like the reverse or the inverse order of what we've been doing. All right, so let's look at an example and see what we're talking about here. All right, so we've given this expression here of 2x squared plus 12x, all right, and we're asked to factor it. All right, and the way to factor it is by finding the GCF, or the greatest common factor. All right, so again, we're going to have these list of factors here, and we have to find the GCF. All right, so the first factors we have of is 2x squared. So that means it's x and x, and 1 times 2, right? Those are the factors of 2x squared. Now we're going to do the same thing as 12x, right? So this is nothing new so far. This is what we did on Tuesday, right? So we have x, we have 1 times 12, we have 2 times 6, and we have 3 times 4. All right, now that we listed out the factors, right, now we have to find the greatest one in common, right? And sometimes it can be numbers and letters, or sometimes just numbers, or sometimes just letters. So in this case, right, we have 2 is our greatest number in common, and they also share an x, right? So that means my GCF is 2x. All right, so now here comes the factoring part, okay? So now we're gonna factor this expression, okay? So once we find the GCF, our GCF is gonna go out in front of this set of parentheses here, okay? Because again, factoring means what to multiply, right? I'm gonna find out what to multiply to get to back to my original expression, right? Here's my original expression, 2x squared plus 12x, and I'm gonna break that down. And I'm going to start breaking it down by taking out the GCF and putting it out in front where you see this 2x's. All right, now I have to ask myself, okay, what do I have to multiply to get back to my 2x squared? Well, the quickest way of doing that is by looking up at your factors here, right? 2 times what gives you that 2? Well, 2 times 1 does, right? So I can put my 1 here. And I also look, I have an extra x, so my extra x goes down there. And now you can ask yourself, does this make sense, right? Does 2x times 1x give me my 2x squared? And the answer is yes, it does. Okay, so now I'm doing the same thing with factors of 12x, right? 2x times what will give me back to 12x? Well, I have to find 2's partner, okay? So if you circled your GCF, right, this is going to make it a little bit easier on you to find out what goes back into my parentheses here, all right? Well, 2's partner is 6, right? Because 2 times 6 gives me my 12, so I know I have to put my 6 back in here, and I don't have any x's because I used it up as part of my GCF, so I don't put an x term in here, and that is going to be my solution, because 2x times 6 gives me back to my 12x, and that's why I know I factored my problem correctly. All right, and we'll look at some more examples here in a minute, but that is the idea of factoring here, right? So I'm breaking down this expression of 2x squared plus 12x, and I'm going to break it up into parts, right? And my first part is the 2x, and my second part is this 1x plus 6, or x plus 6. All right, so you can think of it as factoring is the inverse of distributing. Right, last week we were multiplying, right? Now we're taking up an expression and just breaking it up into factors. All right, so here are kind of the basic 4 steps of factoring. All right, first you want to list out the factors of each term, right? That's using your factors chart if you need to, and list out the factors of each term, right? Again, if we needed our factors chart, we're going to look in this e-learning folder, right? And we're going to scroll down into week 4 here. And there it is, right? That factors chart document is what you should have in front of you when you're working on these types of problems, okay? So after you list out the factors, right, you want to find the GCF of the coefficients or your numbers. And then you want to find the GCF of the variables or your letters. And now you're ready to factor out the GCF. That's what's going to go out in front. And then we're going to fill in the rest of the parentheses based on what's left over. Right? All right, so here's some more examples, right? So we're asked to factor the following polynomials by finding the GCF. All right, so first, again, let's list out all the factors of 9x, right? And we always start by putting our x there at the end. We have 1 times 9, and we have 3 times 3, right? Those are my factors of 9x. And now for my factors of 15, it's 1 times 15 and 3 times 5. So now I find my GCF. I see a 3 in common, but I don't see an x in common, so then my GCF is just 3. Okay, so now that I got my GCF, that is going to go out in front of my parentheses. All right, so if you haven't started yet, all right, this is where you want to start writing these example problems down. All right, so you can follow along and practice with me. All right, so now my GCF goes out in front. And now I got to fill in my parentheses, right? So you're asking yourself, 3 times what gets me back to my 9x? Well, 3's partner is 3, right? Because 3 times 3 gives me that 9. So I'm going to put my 3 back in there. And then I have this extra x. So the extra x has to go back inside my parentheses. And 3 times 3x gives me my 9x. So I know I did that part right. Okay, now we're going to fill out this other box here, this other line here, right? Because I got to put another term in here to get back to my 15. Well, 3 and 5 are partners, so that means the 5 needs to go inside my parentheses. And 3 times 5 gives me that 15, so then I know I did this problem right. Because you can always check by just distributing and checking to see if you get back to your original problem. And what you do, right? 3 times 3x is 9x, 3 times 5 is 15. I got back to my original expression, so I know I have the right solution there. All right, so let's look at some more examples here. All right, example 2, we have 6x squared plus 27x. Okay, so again, list out your factors, right? X and x. We have 1 times 6, and we have 2 times 3. And for 27x, we have an x. We have 1 times 27, and we have 3 times 9. All right, so I listed out all my factors. Now I'm going to find my greatest common factor. All right, I'm going to first look for numbers. It looks like 3 is the biggest number. And now I'm going to look for any letters in common or any variables. And I see that I have an x in common. So then I have a 3x as a GCF here. So once I know what my GCF is, that's going to go out in front of my parentheses, right? Because it's going to be 3x times some other quantity, some other value to get back to 6x squared plus 27x. All right, so now I have to fill in these blanks here to see what do I have to get back to get to my original expression. Right, and the easiest way to do that is by circling. Once you circle your GCF, you find its partner, right? 3 times 2 gives me that 6. So I'm going to put my 2 in here. And then you look to see if there's any extra x's, and I sure have an extra x there. So then that means it needs to go back inside my parentheses. All right, and now I'm going to do the same thing for 27x, right? Who is 3's partner? Well, 3 and 9 are partners because 3 times 9 gives me that 27. So that means my 9 goes in here. And then you look to see, did I have any extra x's? Nope, I don't. So then it's just 9 in there. So then this is my factored solution. It's going to be 3x times 2x plus 9. All right, and you don't have to rewrite it in the bottom. You can just fill in the box here. I just wanted to show you how it looks like when it's without the box there, okay? And again, this is my factor. These are my parts, right? It's 3x times 2x plus 9, right? Those are my two factors or my parts if I break up my original expression of 6x squared plus 27x. All right, let's do a couple more here. Example 3, we have 7x to the third minus 5x squared. All right, again, 7x to the third means I have 3 x's, and it's 1 times 7. 5x squared means I have 2 x's, and it's 1 times 5. So now I'm going to look and see what is my greatest common factor of my numbers, right? And it's just the number 1. And then looking at my letters or my variables, I see 1x in common, I see 2 x's in common. All right, so that means my GCF is going to be 1x squared or just x squared, right? Because we don't really need that 1 out in front. Okay, so now I'm ready to factor, okay? Again, my GCF will always go out in front. And now I got to fill in my parentheses here. How do I get back to my original expression, right? So I have to ask yourself, right, x squared times what will give me back to 7x squared? Well, if I looked at my factor row here, right, 1 and 7 were partners. So that means my 7 needs to go here. And I have an extra x, so that means my x needs to go back inside my parentheses. Now I'm going to do the same thing for this 5x squared row here, right? Well, 1 and 5 are partners, so that means my 5 needs to go back inside my parentheses, and I don't have any extra x's, so that is my final factored solution, right? It's going to be x squared times 7x minus 5. And my last example here, oh, just joking, I got 2 more. Number 4, 15x squared plus 20x plus 25. All right, now I have 3 different terms here in my expression, but that's okay because I'm going to follow the same steps here, right? X and x, 1 times 15, and 3 times 5. I do the same thing for 20x. I have an x down here. I have 1 times 20. I have 2 times 10. And I have 4 times 5. And I do it for 25 as well. 1 times 25 and 5 times 5. So now it's finding that GCF of all 3 terms now. All right, I see 1's in common. I see 5's in common, and that looks like that's going to be my biggest number in common. It's going to be this 5. And now I look for any variables in common, right? I see an x here, I see an x here, but I don't see an x in this bottom row here. That means I do not have any x's or do not have any variables in common in all 3 terms, so that my GCF is just the number 5. All right, so now I'm ready to factor this problem out. So again, the GCF goes out in front, and then I'm going to have this big set of parentheses, and now I have 3 terms to fill in because my expression had 3 different terms, right? This was a trinomial, so that means I have to make it look like a trinomial again with a GCF out in front. All right, so now it's going to be 5 times what gets me back to my 15x squared. Well, 5's partner is 3. And I have these 2 x's extra, right? 2 x's means x to the 2nd power. All right, and now to fill in this box here, I'm going to make it green, right? 5 times what will give me back to my 20x? Well, 5's partner is 4, right? 5 times 4 gives me 20. And then I have an extra x, so that x goes back in there. And now I need to fill in my last row here. All right, 5 times what gives me back to 25? Well, I know 5 times 5 is 25, right? And that's the partner. So that means my 5 needs to go back in here. So now my final simplified solution, factored solution, you should say, is 5 times 3x squared plus 4x plus 5. Now we're on the last one. All right, we have number 5 here. We got 6x to the third plus 9x squared minus 45x. All right, so I'm going to list out my factors of 6x to the third, right? I have 1x, I have 2x, I have 3x's. And I have 1 times 6, and I have 2 times 3. For 9x to the second, I have x and an x. I have 1 times 9, and I have 3 times 3. And for 45x, well, I know it has an x. I know it's 1 in 45, but I'm not too sure what my other factors of 45 are, and I see 4 lines here. Oh, that's right. We can look at the factors chart here. All right, so I'm going to find the number 45. This is going to be here at the bottom. There they are, 1 and 45, 3 and 15, and 5 and 9. All right, so 3, 15, 5, and 9. All right, so 3 times 15, I said, and 5 times 9. Okay, so now I listed out all my factors. Now I'm ready to find my GCF. Okay, so I'm looking up. They all have 1s in common. I see some 3s in common. I see some 9. Oh, 9s are only in common with these two. So it looks like the number 3 is going to be part of my GCF. Now I look for letters in common. Oh, they all have 1x in common. So that's going to make my GCF a 3x. Now I'm ready to factor. All right, so 3x times what gets me back to 6x to the third? Well, 3 times 2 gives me that 6, and x times x squared gives me x to the third. Perfect. Now it's 3x times what gets me my 9x squared? Well, 3 and 3 are partners. And I have this extra x, so that needs to go back in my parentheses here. And lastly, 3x times what will give me back to this minus 45x? Well, 3's partner is 15. And I don't have any x's because I used it as part of my GCF. So that will give me my factored solution of 3x times 2x squared plus 3x minus 15. And that's how you factor finding the GCF. All right, now you guys are ready to do some practice on your own. All right, you'll have practice, skills practice 7.4 to work on.